Okay? All right, so let's try out some examples. Now, if we take a look at our first one, we don't have any coefficients that we have to worry about. So all we're doing is dividing the radicals. And notice that 3x fits into 24x squared. So why don't we just put them together under the same radical sign. Okay. Divide our coefficients. So 24 divided by 3 is 8. And then our variables, x squared over x is x. And it's not completely simplified yet because you know that 8 is 2 times 2 times 2 times x. We can take out a pair. Okay, and that gives us 2 root 2x. Okay, now something else we should discuss is our restriction. Okay, notice it doesn't say x is greater than or equal to 0, which is what we've been working with so far. So why not x is greater than and equal to 0? Well, because you can't divide by 0. Okay? And you know that when we have x is greater than or equal to 0, it means x is greater than 0 and x is equal to 0. And because we have x in the denominator, we can't have x equals 0. And so we just write that x has to be greater than 0. Okay, on the next one, B, notice that you do have coefficients this time and you have radicands. And notice that the 2 doesn't fit into the 5 evenly. You get a decimal, you get 2.5. So on this particular example, we are going to rationalize the denominator. Okay, and so we're going to do that by multiplying by, and then we take a look at our radical and denominator. It's root 2, so we're going to multiply by root 2 over root 2. So we write for square root of 5n over 3 square root of 2 times root 2 over root 2. Okay, so simplify what's in the numerator. We have a coefficient of 1 on our root 2, so 4 times 1 is 4. Square root of 5n times the square root of 2 is the square root of 10n. Divide it by 3 times root 2 times root 2. Well, remember, root 2 times root 2 is the square root of 4. The square root of 4 is 2, so really we have 3 times 2, which is 6 in the denominator. We're almost done. We can reduce the 4 and the 6, okay, but we can't reduce the 6 and the 10, okay? And that's because it's really the square root of 10, all right? And the square root of 10 is not 10. It's not even a number divisible by 2. It's like 3 point something, okay? So all we're going to do is reduce the 4 and the 6. We get 2 over 3, so we can write 2 root of 10n over 3, or if you like, 2 over 3 square root of 10n. Okay, and that's your answer. All right, so let's look at our restriction again. It just says that n is greater than or equal to 0, so why? Okay, and if you take a look, n is in the numerator. It's inside a square root, okay, and your index is even index. Okay, and remember, when you have an even numbered index, you can't have a negative number inside the radical sign, okay? So we write n is greater than or equal to 0. And because n's not in the denominator, we don't have to worry about it not being equal to 0 like we did on A because x was in the denominator. Okay, let's try example C. Now notice we have a binomial in the denominator. When you have a binomial in denominator, okay, you should be thinking this. Okay, binomial. That means I need a conjugate. Okay, and in this case, the conjugate is the square root of 5 minus 7. Okay, so we're going to times our expression by our conjugate, which is root 5 minus 7 over our conjugate, root 5 minus 7. And that's because, remember, this is equal to 1, right? Okay, so remember, put the denominators in brackets, because you're really multiplying a binomial times a binomial. We're going to use the distributive principle for our numerator. So 11 times root 5 is 11 root 5. And 11 times negative 7 is negative 77. Divide it by, use our shortcut, square the first term minus the square of the second term. So we have 11 root 5 minus 77 over root 5 squared is 5, 7 squared is 49. Simplify the denominator. Gives you negative 44. And once again, notice that your coefficients and your, well, actually we only have one coefficient. Our coefficient of 11, our constant of 7, and our denominator of 44 all have a common factor, which is 11. So we'll factor it out of the numerator. And we get 11 times root 5 minus 7 over negative 44. Reduce the 11 into the 44, so 11 goes into 11 once, into 44 4. And we don't want a negative in the denominator. We're going to bring it up to the numerator. Leave root 5 minus 7 in the bracket over 4, and then distribute your negative. Okay, and you're going to get negative root 5 plus 7 over 4, and that's your final answer. Okay. All right, our last example has two things going. Okay, if you notice, in the numerator we have a square root where our index is 2, and in the denominator we have a radical where our index is 3. Okay, that's going to be our first point of interest, because when we multiply by our, when we go to rationalize the denominator and multiply by cube root of 6, remember, you can't multiply radicals that don't share the same index. Okay, so pay attention to that. The other thing that we got here is a cube root in the denominator. Okay, when we want to rationalize that, okay, and we'll just go over here for a moment, I can't just go cube root of 6 times the cube root of 6, because that's going to give me the cube root of 36, which I can't calculate without getting a decimal. Okay, and so this is not rational. Okay, so how do I make it rational? Well, why don't I go cube root of 6 times the cube root of 6 times the cube root of 6 3 times. When I multiply this out, I get the cube root of 216, and I can calculate the cube root of that because the cube root of 216 is 6. Okay? So if you have a an index of 3 in the denominator, then you will want to multiply that by itself 3 times. Okay, not twice like you would if it was a square root. Okay, so we're going to go for root 11 over y cube root of 6, and then times the cube root of 6 over the cube root of 6. That's equal to 1, right? Anything divided by itself is 1. Times the cube root of 6 over the cube root of 6, which once again is equal to 1. But notice, in your denominator, you are multiplying the cube root of 6 by itself 3 times. Okay, and that will give us a rational number. So in the numerator, remember, we've got an index of 2, 1 of 3, and 1 of 3. We can't multiply those together. Okay, so all we can do is just write 4 square root of 11 times the cube root of 6 squared, right? Because the cube root of 6 times the cube root of 6 is the cube root of 6 squared. Divide it by y times, and then we go cube root 6 times cube root 6 times cube root 6, which we already know is 6. And so we will get 4 root 11 times the cube root of 6 squared over 6y. And notice, we can simplify. Okay, we can reduce the 4 over 6 to 2 root 11 times the cube root of 6 squared over 3y. And that is our final answer. Okay, and that concludes this lesson.